You are watching the 9.5 lesson video on scatterplots and regressions. Exercise number 1 is getting us familiar with using the different types of models that we're going to talk about in algebra. So it can either be linear, so a line, exponential, which we haven't talked about in quite a few units, but hopefully you remember how it looks, and then quadratics, which we just talked about pretty recently. And then it says draw a curve, I guess, or a line, depending on what we're talking about here. So if we look at A, if I want to connect all of my points together, it looks like we could draw a line that connects them like this. And if you recall, this is what we call an exponential function, or in this case, an exponential model. B looks like a giant upside down U, so this is going to be, yes, you got it, it looks like a parabola, a quadratic model. C, at first glance it might look like a line, but in this case we are now looking at a decreasing exponential model. All right, let's move on to D. D, here we have our line, our linear function. It's decreasing, but still a line. And in E, it's an increasing line or linear function. And F, yes, this is a quadratic. Okay, great. So now we've talked about the 3 different types of models that we are going to see here in algebra. Let's look at this example in action. So exercise 2 says that a survey was done at Ketchum High School to determine the effect of time spent on studying and grade point average. The table below shows a result for 10 students randomly selected. All right, so it says explain what type of function model would be best based on the table. Okay. Well, we know that the data is not going to be perfect, so what we want to see is if we can develop some type of pattern to see whether or not it is either increasing, decreasing, is it going to be linear, exponential, quadratic is usually the least common type of question that they'll ask in algebra, but still I suppose it could appear. So let's look at the table. Do you notice anything going on with the x values or the study time? So here it looks like to get from 2 to 4 we're adding 2, adding 1, adding 2, adding 3, adding 2, adding 2 again, adding 3. So, you know, even though it goes from 1 to 2 to 3 to 1, I mean, on average, we're increasing by a pretty steady rate. I would say about 2 hours. All right, let's see if we can notice the same thing happening with our GPA. Why don't you take a minute and calculate all of these changes? I'm hoping that you'll get some positive values because it looks like the first few are, the first, I guess, couple are going to be increasing, but take a minute, pause the video, and show those changes. Okay, so if we look at the table here, it's a little tricky to see, or kind of a lot tricky to see. This might not be the best model to start with, but you can notice that we add, then we subtract a little, but then we typically only increase around the 5 to 10 mark, and a lot of times we're actually losing a little bit, like the -2 and -3, sometimes it goes down a little bit. But I don't see anything kind of glaring at me that this would be an exponential model. Overall, it has a pretty steady increase. So that's what I'm going to say here, but you know what, we're always going to check with our plot. So overall, it has a steady increase. So therefore, I think we're going to pick a linear model. But let's just graph them, and this is what part B wants us to do anyways. It says to create a scatter plot on the grid, and what you can do right now, pause the video and just start plotting those points that you see in this table. Okay, so here you can see that we have our scatter plot, and yes, we were correct. It looks like this is going to turn out to be a linear model as being the best fit. Moving on to C, it says determine the equation for the line of best fit using our technology. Now, in the past, in 8th grade, you were finding the line of best fit by hand. So you were probably drawing in your line like this, your line of best fit. You were finding the y-intercept and the slope, and you picked 2 points. Well, we now have this technology that can really help us with our data. So what we need to do is we're going to add lists and spreadsheets, which we're used to doing. And let's just put at the title, let's call this one hours. And then we also need to compare this to the GPA. And in the list, make sure that, let's say, 2 and 64 coincide. So finish typing these in on your calculator. Okay, I'm just about done. Remember, with the last value, you always need to push enter so that there's not a cursor anymore. The next piece that we're going to do, and I will say, I know that these directions are not on the paper, but they're all on the study guide. So you should definitely have your study guide out right next to. If you don't have it, please pause the video right now, pull it out so you can follow along and see what I'm actually looking for. I believe that this is found on the back of the study guide. Okay, next thing that we're going to do is in the next column here. I guess there's a couple ways that you can do this. Let me just pause the video for a second and check to see what is on the study guide. I'll be consistent with that. Okay, so it looks like I do have it shown right in this table. You can also actually do this in a calculate page if you can figure it out and you want to do that. If we have time, maybe I'll throw that in here too. But for now, I want you to actually highlight over the column that we've talked about, never to put your cursor in, this blue box right here in the C column. And what I want you to do is press menu, and of course we're going to do some statistics. We're still going to do stat calculations, but we've been used to using the one variable statistics. We can't do that anymore. We want to perform what we call a linear regression. And I like the mx plus b form. We're just used to seeing that. So in the X column, we need to find our list, and that was hours. So hours was the X. And if you ever need help, just check out your graph. The GPA is our y-axis, and that's it. Then you just push OK or hit enter, and what it calculates for you is the regression. So it tells you what the M is, so it says what the slope is. We can write this out even if it's helpful for you to see. So here we have M is equal to, and here it says nearest tenth, so this will be 1.7, and the B is equal to, is that 62? Yeah, 62.45. That would be 5, because we're rounding again. And this is in the format y equals mx plus b. So in this case, we have y is equal to 1.7 x plus 62.5, which makes sense because check this out. Our y-intercept, if we had just kind of drawn in the line of best fit, looks like it's around 62.5, and it looks like we're increasing by about 2 every time we would move over 1 space. So the slope looks good, it's positive, it just makes sense. All right, so now what we can do in part D, it says use the answer that we got from part C to determine the expected GPA from studying for 8 hours per week. We can see that's not in the table, however, we now have an equation. So we have y is equal to 1.7x plus 62.5, and we are given 8 hours, and remember hours is our x term. So instead of x in our next step, let's just substitute in 8. And I'm going to add the calculate page just so I can make sure that I'm not making any silly mistakes. So what do we estimate? We're saying that y is equal to 76.1, but here it says round to the nearest. I wanted to use a highlighter again. What happened? Here we go. Whole number. So we can expect their GPA to be about 76. And GPAs are usually percent, so we could say 76% would be our prediction. In exercise 3, Mrs. Ruscio had a box of pens in her classroom, and the data below shows the number of days and the amount of pens that were in the box at the end of each day. So at the beginning, there were 40 pens. Then after the first day, there were 27. Then after the second day, and so on and so forth. So you can see that the data is decreasing. Let's see if we can figure out a pattern. So what's going on from 40 to 27? So what are we doing? We're dropping by 13. We lost 13 pens. And then 27 to 18, we're losing 9. And then 18 to 10, we're losing 8. This is weird. It's kind of like we're losing, looks like less and less, -3. So maybe this is not the best way to model this data. I mean, if you think about it, half of 40 is about 20. We're at 27, but what is half of 27? Half of 27 is about 14, and then half of 18 is about 9. We're at 10. Half of 10 is 5. Half of 5 is 3. So it almost looks like we're losing half. Let's put a question mark. So if we go on to A, it says, why should we use an exponential model? So here they're telling us to use the exponential model, and I think I have to agree with them here because we don't have a steady decrease. It's not like it's going down 13 and then going up 1 and then going down maybe 14. It looks like we're losing about half of the pens as every day goes by. So half of the pens, actually we should say about half of the pens remain after each day goes by. If it were quadratic, we would have seen maybe like a decrease and an increase of the data, or an increase and a decrease. And then with a linear, we would have seen a constant increase or a constant decrease overall. All right, so B says use the calculator to find an equation that best models this data. And we need to round to the nearest tenth. Okay, so we need to type this in our calculators, in our list and spreadsheets. Hey, look it, I already did this. Okay, so here we have the pens and the days. And then we're going to go ahead and do this regression again. So you can use your study guide. You're going to hit menu, then statistics, stat calculations. But instead of picking the linear regression, we don't want that. We want an exponential regression. same thing. We pick the same list. So here we need, what are we looking at? Day. Oh, I passed it. Day for my X value, and for my Y value, we need pens. Hit enter again, or hit OK, and here is our exponential regression. Now, you might wonder what the r squared and all the other stuff is in some of these, and we'll talk about some of those numbers later on. For right now, we just need the fact that they gave us our equation, and y equals a times, and I'm just going to use parentheses, b to the x power. This is how we usually see it. So here we have a is about, so a is rounded to the nearest tenth, 48.7, which makes sense. That's our y-intercept, remember. It's a little higher than what we had, but pretty close. And our b value, which is going to be our base, our multiplier, let's hope it's a fraction or a number smaller than 1, and it definitely is. It's about 0.06. Oh my goodness, isn't that almost close to a half? It sure is. So here is an equation that best models this data. Now, if I wanted to show this on my calculator, I can add a page. I can add data and statistics, which is 5. And if I hit tab, well, right now you look at it and you're like, this is a big mess of points and it has no rhyme or reason. What happened? Well, it's because we haven't told the calculator what we want the x to be, and we want this to be days. So then the points all align, and then if we hit tab again, we want the y-axis to be hours. And no, we don't want it to be hours. Just kidding. I'm looking at a different set of data. We wanted this to be pens. Obviously, I knew something was wrong when it produced basically a linear model. We don't want that. We want pens. Much better. So now this models what we have to the right. You can even go in menu, and if you analyze the graph, you can add in a regression line, because you can see regression right here. It's number 6, and we want a exponential regression, and as you can see, it'll put this right on the graph for you, and it will show you that exponential model. It will give you the values. It won't give the a and b values rounded. You'd have to do that yourself, but you can actually do this for a linear regression. You can do it for an exponential. You can do it for any of the regressions that you do. Sometimes if they don't give you the graph off to the side, which they did here, we like to show it ourselves. Heading down to exercise number 4, they're giving us a table of widgets and the cost per widget that a factory is going to, what does it say? The cost per widget produced by a factory generally drops as more are produced, but then starts to rise again due to overtime costs and wear on the equipment. Okay, so if we look at this data, they showed it to us in both the table and the graph. And if we look at answer, or if we look at what they're asking us in A, it says, why should a quadratic model be considered for this data as opposed to an exponential or linear? Well, if you look at this data, it's doing exactly what it says it was going to do. It was going to start high, then drop low, but then get back high again. So this data is modeling a U shape, which is the shape of a parabola. Now, as you can see for part B, I have already typed in all of my data into the calculator just for time purposes. And what we need to do is we need to find an equation that models this data. So you guessed it, we're going to go into that equal sign in the C column, menu, stat calculations, and in this case, we're not going to do a linear, we're not going to do an exponential, we are going to do a quadratic regression. And here, let's be careful, this is widgets. Where are you, widgets? I have a lot of data in here now. There it is, widgets, and then my next is cost, I think is what I put in. Yep, there it is, right at the top. And all you have to do is push enter, and it's giving you the equation. Notice how it's cut off, but at the bottom it shows you what our equation is, and that's going to be y is equal to ax squared plus bx plus c. Okay, no surprise there. We have a quadratic equation, standard form. And what we actually have to do here in this problem, we're going to change this to hundredth, or no, thousandth. Because if we don't round to the nearest thousandth, we are going to get a 0 as a leading coefficient, and that would not make this a quadratic, and that would be really bad. We get a linear function. So here we will have y is equal to, and our a is, oh, that was weird. I didn't mean to do it that. I just typed, or I must have hit that with my hand. So 0.001 is our a value. So 0.001x squared. Our b value is going to be a negative, so minus 0.25, and that's going to stay as 0x. And then our constant, which is our c value here, rounded to the nearest thousandth, will be a positive, so plus 16.863.